Stop. I hear what I want to hear. I heard something that I can't.
Repeating this just so it'll be on the video. But these are the formulas you need on the back of the formula sheet for your test from sections 1 and 2 of this chapter. Which shape are we doing today?
Oh, maybe mine printed front and back, but maybe yours didn't. Oh,
Yes, find out. Those are matched today. Found out like 15 minutes ago they canceled. So we're going to do a practice round 9 or 8 holes on pairs out. Okay, let's see.
Thank you.
Does everybody get one?
Yeah, I think I'm
Does everybody have these formulas so I can get rid of those? Probably want to shoot. Oh, get rid of them. So now we can flip our paper back over here.
Stop throwing trash on the table.
So, gonna put the same exact picture up there 4 days in a row. This is day number 3. We're talking about hyperbolas. What did we talk about yesterday? What was the day before that? And what's tomorrow? Parabolas. Trying to take away all suspense. All right. Now, you do not need to write that down. You don't need to take a picture of it or anything like that. The only reason I put that up there, I know it looks super confusing, is just there's going to be some words we're going to talk about today, and just so you have a general idea of what it's talking about. Knowing what the shape looks like actually does not have any effect on whether you can do what we're going to do today. Okay. For all intents and purposes, as much as that looks completely different than what we did yesterday, today's lesson is going to be almost exactly the same. Okay, so hyperbolas and ellipses have a lot of similarities. Okay. So notice they both have a vertex and a covertex. Okay, the covertex is not even touching the hyperbola. Okay, but it still has one. It makes that little box thing. What is different as far as just looking at the word? I know the shape looks completely different, but what's actually different? The asymptotes. Yeah. So that little box, you see they have those little orange lines. Those are asymptotes. So we're going to see some stuff about asymptotes today. Other than that, everything on there, they're the same words. Now they might be in different spots and how they work is different, but they're the same words and they're going to work pretty much the same way. Okay. So there's hyperbola. Let's pull up our paper for today. All right. Except so we have our formula sheet. We have our hyperbola box down here. Look at our hyperbola box. And other than that asymptote row, what is different between the hyperbola, all these rows, and ellipse? Okay. Now that looks more different than it really is. Now, with up here with addition, does order matter? So if I flip those two around, would it make any difference? The whole, like, if I have 1 plus 2, it's the same thing as 2 plus 3, right? All right. So notice that here, the A for vertical, the A is underneath the what? The Y. For hyperbola, for vertical, still vertical, the A is underneath the Y. That's the same, correct? And then over here, for horizontal, the A is under the X, the A is under the X. So where the A is located for vertical and horizontal is exactly the same. If it's vertical, the A is under the Y. If it's horizontal, the A is under the X. That has not changed. What does change is, yes, the A squared always comes first. We always put the A squared first. And so therefore the order for vertical does end up getting a little bit backwards. The big difference is what? There's a bigger difference. Somebody tell me what the big difference is between ellipses and hyperbola. Subtraction. That is important. The formula for center, vertices, and foci, are they different in any way, shape, or form? No. Now there's one more formula. Hopefully it's on your formula sheet. The one for covertices. All right, remember we penciled it in right here in between. Yeah, so you should not have to write it in again because you already have it, right? We said we're putting it in between because it's the same formula for both. So if you don't have covertices, write it in, but otherwise you should have it. What is, if you have it, what is it?
H plus minus B or H comma K plus N minus.
Okay. So that formula, exactly the same as well. Now, some things that are different. Well, we do have this whole asymptote equation because we have asymptotes, so that's completely different. But notice the whole A, B, and C together. For ellipses, we use a squared equals b squared plus c squared. What are we using now? Okay, so the fact that that's changed, what does that tell me about A, B, and C? I mean, they're in the same spots, but what about how the size of those numbers? So the c squared is now the largest number. So before a squared had to be the largest. Now c squared, the c is going to be the largest value. And the main difference here is that a is not necessarily larger than b. A can be larger than b, a can be smaller than b, or a and b can even be the exact same number. Okay, so that's important. That is a very key difference between ellipses and hyperbola. So for ellipses, a had to be larger than b. Not so for hyperbola. A can be bigger, smaller, or the same. Okay, but again, a always comes first, b always comes second. That's how I tell which one's which. All right. So for number one, which one is the a squared? 144, because it comes first. Which one's the b squared? 100, because it comes second. I can also just look at this and very quickly figure out, is it vertical or horizontal? Vertical. How do I know it has to be vertical? Yeah, the y comes first, so this one has to be vertical. Now we saw ones like this. Remember, we did like the more complicated ones first with ellipses and then the simpler ones like these. So here we're starting with these. Where's the center located? 0, 0. So change colors. The center is at 0, 0. And I already started writing. What is it asking me for? That probably would be a good thing to. Vertices and foci. Okay. So I didn't technically even have to write down center on this one. Vertices is h comma k plus or minus a. Right here. As we say, we're in a vertical. Well, I know there's my h, there's my k. What is a? What is b? Okay. So we'll switch colors. Where are my vertices? Good. So, I don't need, it didn't ask me for my co-vertices, so we won't do that. However, does that mean I don't need to know what B is? Why? Because we got to find foci, which uses C, and I need A and B to find out what C is. So let's plug into our formula. C squared equals A squared plus B squared, which means C squared is what? So C would then be the square root of that. Can I simplify the square root of 244? Pretty sure it's divisible by 4, so which means I should be able to. 4 times what? 4 times what? I know 4 breaks into 2 and 2. Does 61 break into anything? So that's 2 square root of 61. So where are my foci? And yeah, if you want to do plus or minus, really you could have done plus or minus with both the foci and the vertices on this one. Questions on that one? So despite the fact that we moved on to a different shape, that was extremely similar to what we did ellipses, right? Okay. Go ahead and try number 2. Check your answers. That what we got on number 2. All right, so we're going to skip on to number 4. Where is the center located for number 4? Yep. What is A? Yeah. What is B? Root of 85. I can try to simplify it, but let's see here. 85 divided by 5 is 7. All right, 5 and 7. Nope, nothing. I'm breaking part of that. 17. Okay. Yeah, so either way, still. So I'll leave it just like that. That's okay. So there's my center, there's A, there's B, everything we need to go into vertices. Now we've got some fractions, we got some square roots, that's okay. This means our answer is not going to be the prettiest looking, but it doesn't actually make this any more complicated. Vertices. Oh, sorry. First should have asked, is this vertical or horizontal? Horizontal. Okay, we know it's horizontal because the X comes first. So we're over here. Also, this is our first example we've seen where the A is smaller than the B. So we're plugging into vertices. So we have our H, which is -1. -1. And we're going to add what to that? Yeah, square root of 5, which is our A, comma, K, which is 19/2. And then we're going to have -1 minus square root of 5. That's supposed to be a 5, comma, 19/2. Or if you prefer, -1 plus or minus square root of 5, comma, 19/2. Okay. Not the prettiest looking thing, but again, when they give it to me like that, that means there's nothing else I can do with my answer. It actually makes it easier because I'm just plugging them in, and that's it. So there's vertices. I do need to figure out what C is so we can find our foci. So we have C squared is equal to, well, there's A squared and B squared, 5 plus 85. So C squared is 90. 90 is divisible by 9, so it definitely can be simplified. What square root can I simplify that to? 3 times. Yeah, so I was thinking it was 9 and 10. Yeah. So what's the foci going to be? Now, again, normally we do get numbers that are whole numbers, not radicals or fractions, like on number 5. But if they are square roots and fractions, it doesn't really make it any more difficult. It just makes the answer look kind of strange. Go ahead and try number 5. Your 5-minute break after this. All right, check your answers to number 5. Any questions on number 5? We'll do our 5-minute break. Oh, right. X, right. Yeah, that is tricky about the hyperbolas because the x is not necessarily first. This number is with the x, so the center. I'll write that down. Center and 0. So that's with the x. So it's got to be in the x spot. Whereas 0 y spot. All right, so number 7, what information can we get just by looking at what they give me in number 7? Yeah, I heard horizontal. How do we know it's horizontal? Yeah, so it's the X value that's changing in both the vertex and the foci, so it's horizontal. Yes, we can look at it and figure out H and K. Where do we get H and K from? K is 1. Okay, so our foci, because it has a square root in there, tells us pretty easily our H and K. So that's our center. Now we're trying to write the equation. Because I know it's horizontal, I know X has to come first, correct? And so, and I know the center, so I know it's X what? Minus, and Y. All right, that square root of 106, what is that? What does that tell me? Yeah, but what is 106? C, so that's not C. So that's C, so yes, I know C squared is 106. All right, now I know that the vertices, the values that's changing is 0 and -10. So it's going from -5 to 0 and -10. That's my A. So my A has to be 5. Okay, and we know A always has to be first, right? Or our A squared. So what's going to go underneath here? 25. All right, so that means the only thing left is to find our B. So 106, 25 plus B squared. There we go. That's number 7. Go ahead and try number 8. All right, did everybody have a chance to finish number 8? Okay. So remember, so was it vertical or horizontal? Vertical. So that means the y has to come first, right? Well, this is my h, meaning it's in the x spot, right? And that's my k, which means it's got to be in the y spot. So that's got to stay with the x, and that one's got to stay with the y. So yes, whenever it's vertical, you're always going to have to switch those. X is going to come second, y is going to come first. Yeah, so we'll do this one from the beginning. All right. So this is our h, k, and then there's my c. So my center is -8, 5. Because it's the y value that's changing, then I know the y has to come first. This is the y coming first. This is my y value, so I put it with the y. That's my x value. Put it with the x. For the numbers in the middle, let's start off with the a, because that's what I get from the vertices. So I'm going from -5 to 18 and -8. Well, let's go from 5 to 18. How many do I go up from 5 to 18? 13, right? It's 18 minus 5 is 13. So, or I could say 5 minus 13 is -8. So either way, I'm adding and subtracting 13. So my a is 13. Well, if a is 13, what's 13 squared? And so my a always has to come first. And then c squared equals a squared plus b squared. Now my c is a mixed radical. We had one of those last time. I have to square the number in front. 5 squared is 25. Square root of 10, which is 10. 25 times 10 is 250. We already know a squared is 169 plus b squared. Uh, 250 minus 169, I'm going to assume is 81. That's where that comes from. I'll leave that there. Go ahead and try number 9. Number 9 is same type of problem. Try number 9. Did we finish number 9? So then this was another one that was vertical. So you had to switch as far as your X and Y or H and K. K had to come first, H came second. Okay. Questions on number 9? All right, you can actually X out the next 3. I have an error on those that I need to go back and fix. So you can put in X through numbers 10, 11, and 12. And so then we're going to do 13, 14, and 15 together. All right. Now, the asymptotes. First, notice that the asymptote equations here don't look the same as far as the same form as the ones on your paper, correct? However, all we care about is the slope, okay? What is the slope for number 13? 12 over 13. Are we okay with that right there is our slope? Now you'll see one's positive and one's negative, and that's because right here, slope is plus or minus, okay? So you're always going to get one positive, one negative. There's our slope. Now, the slope gives us A and B, because slope is just A over B or B over A, depending on which one we're in. So that means as soon as we figure out if it's horizontal or vertical, we can just look at the slope and figure out what A and B is, okay? How can we figure out if this one's horizontal or vertical? That's right. It's in the X spot, the plus or minus. So the X one is what's changing for the foci, which tell us it has to be what? Horizontal. All right. That one right there. So that means, is my slope A over B or B over A? It's got to be B over A. Again, kind of wrote on that a lot. But my slope, because we know it's horizontal, my slope is B over A. So 12 is the B, 13's the A. Are we okay with how we figured that out? All right. Now, can I look at the foci and figure out where the center is?
Yes.
That's my H, that's my K. So I know H and K, and I know A and B, right? Isn't that everything I need? Yeah. So we know it's horizontal, so the X is going to come first. X what? Plus 7 over A squared always comes first. I know A is 13, so minus Y and then B squared would be, and there we go. So that's the only one that actually looks and works differently from ellipses. And that's probably the easiest one we've done yet. Okay, there should be 2 more problems. Go ahead and try those last 2 real quick. We'll be done. Finish a little bit early. plus 2. Questions on those?
Okay, but yeah, over one.
Yes.
Okay.
So explain this. The homework assignment that will be on Google Classroom is different than this one. Okay. So you can either do the one on Google Classroom or do this one. If you do this one to make them the same type of problems and equal number, you would just skip those problems on the one on paper. Does it make sense?
Yeah.